Hello and welcome. Further maths integration today. Nothing too hard. Actually a very nice gentle integral that will involve a few basic techniques. How hard will that be? Probably with my usual rating that I use in my papers and my books. Probably a 3, maybe 3.5 if you want. So nothing complicated. So it's the integral of the arctan over x squared dx. What technique is involved in this particular integral? It's quite clearly integration by parts. We will be differentiating the arctan and we'll be integrating the x squared. But I fancy doing it a little bit different. Sometimes I do crazy stuff and just for fun, I suppose. So I'm going to do it's integration by parts, but done in a very strange way. So I'm going to differentiate because I'm just looking at this particular integrand, and I can see that I'm going to get something which looks like that if I differentiate a very special product. What's that product? Well, I'm going to put 1 over x in this product and the arctan of x. My rationale for something like this is when I do the product rule and I differentiate the first term, that's the 1 over x, I'm going to get a 1 over x squared times the second bit undifferentiated. So I'm going to get something which looks like that. And I'm going to deal, of course, with the other bits as I come along. So here we go. Differentiating that, I'm going to get minus 1 over x squared times the arctan of x untouched, plus the other way around. So this time I'm going to leave the 1 over x alone and I'm going to differentiate the arctan, which is a very standard differential which we should all know at further maths, 1 over x squared plus 1. So what do I do next? Once I got this line, I'm going to integrate my entire equation. Normally I wouldn't be putting integrals there, I'll be doing it as I'm going along with respect to x. So dx and dx. And let's see what happens. Integrating and differentiating with respect to x. This will give me 1 over x times the arctan of x. And this particular integral, I'm going to split it into 2 integrals. So I'm going to put the minus in front. So minus integral 1 over x squared arc tan of x dx, so that's this term here, and I'm going to split that to a second integral 1 over x squared plus 1 dx. So as you can see, this is the integral that I'm trying to find, so I just need to rearrange it a little bit. So let's move this integral to the left. Conveniently we got a minus, so we can make it plus. So integral of 1 over x squared arctan. Take this term to the left, minus 1 over x, the arctan of x. And what about him? His partial fractions is irreducible. I'm going to do it by inspection. You can actually put full workings. You can write this as something over x, of course, plus bx plus c because of this irreducible quadratic term there, but that's not too difficult to do. We can do it by cover up, or we can just guess the numbers because it's so simple. It's something over x and something over x squared plus 1 dx. And what numbers need to go in there? Well, when x is equal to 0 is 1 over 1, so that's going to be a 1. And let's see how this will work now. We've got an x squared here, and we need to cancel because we got a 1, so clearly we need a minus here and an x there, so we got plus x squared minus x squared, cancel and the plus 1, that's it. Okay, but you can do, of course, your partial fractions. So I'm going to finish this integral now, which of course this is what I'm required to find. This has already been integrated, 1 over x, the arctan of x. That will give me, of course, plus the log of mod of x, and this is by recognition is bottom differentiates to the top, but for a factor of 2 that I don't have in there, so I'm going to put a half in front of it, a half log. I don't even need mods there, but you can if it doesn't really matter, because of course this quantity is always positive, plus c. And do we need to do anything else for this particular one? I guess not. Okay, who's laughing now?